Hey guys, welcome back. So yesterday we were talking about voltage drop in series circuit. Like we mentioned before, in a series circuit, the sum of all the voltage drops across all the resistors must equal the voltage applied to the circuit. Therefore, you're gonna get to that point. For starters, we gotta apply Ohm's law. Ohm's law states that E over I times R. And with this, we can get started. So, first of all, we got voltage and resistance. So as we said before, in a series circuit, because there is only one path for the current to flow through a series circuit, it must flow through each and every resistor. Each resistor limits or impedes the flow of current in the circuit. Therefore, the total amount of resistance to current flow in a series circuit is equal to the sum of all the resistances in that circuit. So what we have to do first is to find our total to solve the circuit. And we're gonna say this is, for example, resistor 1, resistor 2, resistor 3, and resistor 4. So with that being said, we got 10 ohms for resistor 1 plus 14 ohms for resistor 2 plus 16 ohms for resistor 3 plus 8 ohms for resistor 4, and that will give us our RT total. And we go to our amazing calculator, and we got 10 plus 14 plus 16 plus 8 equal 48 ohms total. So there you go. So now that we got our total ohms, we can solve the circuit. We already know the total voltage. Calculating series circuit values. The rules that can be used with Ohm's law for finding values of voltage, current, resistance, and power in any series circuit are: first, the current is the same at any point in the circuit. Second, the total resistance is the sum of the individual resistors. 3. The applied voltage is equal to the sum of the voltage drops across all the resistors. So, since we already got voltage and total resistance, okay guys, so we already got voltage and resistance. So, we already know by adding all the voltages that total voltage is equal to 24 volts. So we already got voltage and resistance. So now we can find current. So I total equals so we already know that total voltage is 24 volts and we got total resistance. Now we can solve for I2 total. So if we go, for example, 4 divided by 48 equals, you got 0.5 amps. Boom. And if you're trying to find, for example, voltage, all you gotta do is I times R. So if you go I times R, it should be 0.5, which is half of an amp, times 48 equals, you go back and boom, you got 24 volts. Now, for example, if you wanted to solve for power, and don't get frustrated about this, but power in watts and true power is basically the same. So remember, guys, if you ever hear power, watts, true power, it's the same thing. Different notation, you can call it, but it refers to the same. So, for example, if you try and find power equals E times I equals, so we got E, and we got I. So 24 times equal, we got 12 watts. And voila. Now, for example, if you were trying to find power, and eventually you're going to understand there's a reason, a very important reason why they call it true power. And say you want to get to power, watts, and you don't know, for example, the current, you got another equation, a secondary equation, which is basically power equals E squared times R.
12 watts. And another formula for solving watts or power is goes in P equals I squared times R. So for example, in this case, we can go, we got I squared, so we got 0.5 times 0.5 equal I squared. It's basically the number multiplied by itself. So we got 0.25 times resistance total, which is 48 equal, and again we get to the same number. So if you get to the same number, guys, like this, and you got the right total. And This is basically it. The theory behind it sounds very complex, but once you know, and even I forget, as you can see right here, I made a tiny mistake. But you can memorize Ohm's law. You might forget it one day or two, like if you're too tired or whatever. But don't feel bad. Even I make mistakes. I've been over 30 years doing this, so, and don't worry about it. Practice, practice, practice. And as you can see right here, different formulas get you to the same results. The important things is double checking, triple checking your numbers. Always do it. Never assume you're right just by thinking it. Do the calculations. Many times the inspectors, the cities, engineers, utility companies, they're going to tell you, have you done the calculations? And in a few of your company, who did the calculations, and show your work. So it's very important to show your work. But as you can see, very simple stuff. Tomorrow, guys, we're going to talk about parallel circuits.